Let's take a tour of the wastewater treatment process. Incoming wastewater must first pass through a series of screens and separators. Large visible debris is strained out, including fiber and wood fragments, bits of plastic and fog, which stands for fats, oils, and grease. These oily substances are lighter than water and naturally float. Oil-water separators and skimmers are used to remove fog. Finer screens remove smaller particles of grit, such as dirt and sand. All the removed waste material is washed and compressed. Then it is discarded as landfill. What happens to the wastewater next? It is sent to large round settling tanks to separate the remaining solids from the liquid. It can take a while for the finer material, called primary sludge, to slowly settle. This sludge is eventually pumped from the bottom of the tank to another area for sludge thickening, the removal of excess water. These solids go to the sludge digester. Anaerobic digestion uses microorganisms to break down organic pollutants without oxygen into gaseous products, including methane. Anaerobic filters are temperature sensitive and costly, but the methane can be used to generate heat and electric power, offsetting some of the cost. The remaining solids are dewatered, dried out even more, and finally sent for dry sludge treatment to be stabilized for other uses, such as fertilizer. Meanwhile, the wastewater from the settling tanks and the water removed from the sludge flows into a specially designed bioreactor. For example, an aeration tank of activated sludge process. This is where most of the water treatment happens. Air is supplied so that microorganisms in the wastewater can biodegrade the remaining pollutants aerobically. Bacteria break down the organic matter, which contains carbon, to form carbon dioxide and water. This is similar to what occurs in nature at the bottom of lakes and rivers, but that process takes much longer. After even more settling and filtration, the secondary sludge created by this process is sent for sludge thickening. The water moves on for disinfection, removal of any harmful bacteria using chlorine or ultraviolet light. The clean water is then ready to be reused or discharged into the environment. You can see how the wastewater treatment process relies on microorganisms at key stages. Often a costly combination of anaerobic and aerobic processes is needed. How can we minimize the cost of using microbes to treat wastewater?